record or recording of the webinar in the area where you log in our GoToWebinar area. But let me start with very simple file. Okay, let me check something. Okay, you have you can see this is our CAD system, CADdirect. And this CADdirect, we integrate in this CADdirect Print2CAD. But first, as a first step, I will simply start the moment here, start our program Print2CAD. So this is start print PDF to DWG. And this is a batch converter for PDF files. That's the first step. You see, in AutoCAD, you have no any batch converter. You have to import every file separately, and you have to import every page separately. It's a lot of work. Here, you can choose a lot of hundreds of files, PDF files, and simply import it and convert it into in the DWG. You can see here the DWG version. Okay, I take so this DWG 2004, 2006. There's no difference what you take because 2004 is level enough for conversion. And I will choose now one file. Let me check this file, how it's looking. Okay, let me take here. Oh, this is my, I have to go here on webinar. Moment here, this webinar, and let me check this file. Okay, let me view this file using our internal PDF viewer. This PDF viewer is not a competitor product for Adobe and other viewers, but this viewer is fantastic for construction drawings. And we have here fantastic tools. So here on the screen, you can separate the only 4 possible PDF entities. You see, PDF file is not a CAD file. In PDF file, you can define only 4 entities, 4 elements. Text, native text, first element, then polyline, then raster image, and then boundary edge. Only 4. So, and you can separate here. Look, looks fine, yeah? But let me go here on characters. Now we separate the text. You see, this is only the native text here, but this is not a native text. And it's not true. Then you go on image. You can see this text is an image, this text is an image, this is an image, this is image, this image. Like in this PDF, you can see 1, 2, 3, 4, 5 inserted images. Here, if you go on path, you can see this is everything a path or polyline. This can be a line, or there can be a Bezier curve. And if you see here, this is not a native text. This is a line. And if you see, for example, here, these are not circles. These are simple polylines. And if you zoom, for example, this element, you can see the bad quality of this PDF. This was circle in CAD. Now you have something that looks absolutely not like circle. And you can go here on field patch, boundary edge, and you see this text is not a native text. Look, and this word, LED. Do you know what is it? This is a boundary edge in 300 dpi raster, because the most PDF files are made simple in 300 dpi raster. Like the accuracy of this PDF files are only 300 dots per inch. So you can see the bad accuracy on the curves, like here. Of course, if this, because this is orthogonal raster, you can see the bad accuracy on horizontal vertical lines, but on the curves, you can immediately see the bad quality. But you can see also this bad quality if you go here on path and zoom here in details, like these 2 circles, you see? And this is a big disaster by PDF files, because if you import these files in CAD systems, you will get something like this. And what happened if you want to recognize this as a circle? But can you see, this is almost something different than a circle. For this task, to recognize circles, to recognize this text as a native text, to recognize this text as a native text, okay, and this line as a lines, you need artificial intelligence methods. Why? Because artificial intelligence make a decision based on probability. It is a fuzzy logic. It's not logic yes or no, like in conventional software. If you, for example, import something in AutoCAD, you will get this simple as a raster image. This you will get, this everything you will get as an image. This, for example, this text, like here, you will get maybe in AutoCAD as native text, but only if this text is really made by spatial fonts. So now you need really artificial intelligence methods. And this is the power of artificial intelligence. Okay, I will show you something how we can do work now. Because we have here raster images, you have to take care for raster to vector. And because we have a lot of text, what is not a native text, we have to take care for optical character recognition. And because the coordinates are in terrible quality, we also have to take care for coordinates calibration. So like these 3 steps, okay, are very important. And the optimization is something important too. For example, layer recognition. Because if you see this file, there are no layers. Can you see it? There's nothing. File, let me go here on layers. There's nothing. Okay, so there, layer. You see only one layer. Now, so let me start now the recognition. First, I want to show you is what you will get without any recognition. I switch every raster to vector off. I switch so everything off, and here optimization, everything what is artificial intelligence method, I switch off. And let me start now the conversion of this file. And let me check how it looks in AutoCAD and other systems, simply without any conversion. You see, moment, this is okay. I have to only do. So the most so if you import it in normal CAD systems, you will get this as a line. This we get a boundary hedge. This maybe we'll get as a native text, okay? But you see circles. So this circle recognition is not done really. You can see here, and you can see the quality. Okay, and this is and no layers. If you go here on Edit and Home, and you can see we have no layers. Okay, but this was I didn't switch off the layer recognition. Let me go here now again. So optimization. You see layer recognition, artificial intelligence layer recognition was already activated. Okay. So, and what's happened with raster pictures? In normal CAD systems, you will get raster pictures like here, like simple raster pictures, like nothing vectorized, because vectorization is a very, very complicated task. And this task can be done only by artificial intelligence. This is what we'll get, for example, if you will read it in AutoCAD. This text you see as a raster picture. This text, this table, and simple as a raster picture, and this as a raster picture too. So let me check now here the possibilities of artificial intelligence. Okay, let me go on optimization. Artificial intelligence line type recognition of horizontal, vertical lines, lines with inclination. We are able to recognize dash, dash, dot, and dotted lines. Artificial intelligence recognition of layer structure. So here is everything native text. Here you can optimize the text side, but this is now fine. Okay, raster to vector. Artificial intelligence line and symbol recognition. I have no walls, then I switch it off, the artificial intelligence recognition of walls and hedges. Circle and arc recognition, but this is only recognition in raster pictures. You see, if you activate this function raster images and scan vectorization, we switch automatic all functions you need for a normal scan drawing of architectural drawing. Because we have no circle and arcs in our raster pictures, I switch it off. We don't have any 45-degree inclination lines. Let me check it again. So look. This is a text, this is a text, this is a text. And this is, you see, this is what I want to vectorize. And in this table, we don't have any 45-degree lines. We don't have any arcs. But this is something different. This will be this is what we recognize as a text, as a symbol. So then go here on raster to vector and switch off these lines at 45-degree inclination AI recognition. You see, if you activate only what you need, you will get a better recognition. Okay, so now we don't have any small holes in pixel traces. I switch it off. We don't have any free pixels. I switch it off. Okay, now adjustment. We don't really need to adjust this table. The table is already horizontal and vertical. Here, vectorization 2. So if you want to adjust it, for example, if the table will be is not really so inclinated, you can go here and input here this adjustment angle. Why? So what is only one problem? You see, you see now we separate here every raster picture, and this is the only one we want to recognize horizontal vertical lines. If we will get here a very, very bad inclination of it, you can define here a line, like from here, you tell me here, this have to be horizontal. And very important thing is following. You see, in a PDF files, you can place a lot of different raster pictures. So like now this inclination correction is only for this picture. This is the reason that we offer this tool, so that you can define for every picture a different rotation angle. But you will see, save and edit, this rotation angle is almost 0 degree, but let me leave here by 0.186 degree. Okay, good. Now we go to vectorization 2. This is only for digital photos. We don't have any digital photos in this drawing, so we leave it. Vectorization 3. So I don't want this this raster image in the background, and this is what I leave here. This optimal threshold from black and white. This is what I'm speaking later about it. I'm going to vectorization 4, and here I need edge lines and corners. Bang, and you see we put here the correct parameters. And vectorization 5. I want to recognize right corners. Of course, we have in table, but we don't have any small circles. We don't have any frames rectangles, but I want, so we don't have any small dashes for crosses, but we have a symmetry. The table is symmetric. It's very important and fantastic function you can use to make this recognition better. Okay, now I'm going for something very important. Text recognition. What's going on? You see, we have to recognize this and this and this text as a native text. How we are doing it? Let me go and again. We have text as image, we have text as path, and text as field path. So you can go here on optical character recognition and make this automatic artificial intelligence text recognition. Language is United States English. We have horizontal and vertical text, but the primary text, the most text, is horizontal. We have here text as line with the text as hedge and as raster image. It's fine here. I activate now an undo function, and here with these parameters, I want to see in preview what we suppose with these parameters to be a text in this drawing. Because you see, artificial intelligence is very smart. But look at this. Our artificial intelligence think this can be a vertical text. Why not? This is a vertical 11,111, 11111. Why not? So let me go here. Here, the artificial intelligence suppose it is a text 00 or 00. Why not? It looks similar. Here, you see we make a lot of errors, but you can clean up. Here we are fine. You see vertical text. Here we recognize this is a vertical text. Here you see this error here and at the end. But you can clean up it. Go here and tell our artificial intelligence the text is maximum maybe 80 pixels, and check in preview how this parameter is working now. You see our artificial intelligence will make later in other steps less errors, okay? But on this kind, you can clean up a lot. You see, this is only the first stage. Also, our AI is thinking in this first step, again, this is all, okay? But here, we will able to recognize that this is not a text, you see? Now it looks more better, okay? You see, we was able to recognize. Okay, this is fine for this first step. Let me go and convert it. I don't calibrate any coordinates. We are doing it now here with these parameters. And let me check what's going on, how our artificial intelligence inside the program is able to recognize the text. But there are a lot of stages. Dictionary stage, the stage of probability of a text. For example, how probably is the text 1100, 111? Okay, here is something very important. You see, we are not able to activate for construction drawing and the dictionaries, because 50% of a text in construction drawing is something what will never find in dictionary. Abbreviations, parts numbers, short texts on etc. etc. And now you can see here we think that this is then now we can simply correct it. Profile. So go through, uplight is okay, trim less. You see only in 15 texts our artificial intelligence is in doubt. Is this correct or no? From here, lighting. Yeah, this is very, yeah, the reason was here because this was written, you see this with this kind of L, and we are not able to recognize this is capital L or not capital L. That we go here, LED, you know, we was able to recognize it, but this is what we not find in any dictionary, and we put it here, is this correct or not? But only 15. Now we go on OK. Okay, and let me view it in CADdirect. And now you can see we was able to recognize this as a native text. This as a moment, going back. This as a native text. We was able to recognize this as a native text. We was able to recognize this table. Perfect. Can you see this perfect job? We was able to recognize this text. You see, this is LED here, and this text as a native text. If we mess up something like this here, okay, you can every time go here on AI tools and tell here undo it. I need a symbol again. So let me check this one. You see, we recognize go and this OO. Simple, go here and tell undo it, and you will get symbols. So now you see this is not recognized, but here you can see this is recognized as a text. But what's going on if you have a lot of errors like this? Of course, this is artificial intelligence, and It can happen something like this. I show you another method. In this case, okay, you can go here on optical character recognition and activate interactive recognition of OCR and symbols. Auto-generate optical character recognition areas with this button. And now you can edit this, what we suppose to be a text, and look how it works. So now here in this editor, you can see we suppose that this is a text. Simple go here and delete it. Delete this and this. You see here, delete. Delete this too. Okay, now it's perfect. I'm going now on save and edit. Okay, and start. Like in this interactive method, you can on beginning clean up what is not really a text in a construction drawing. You have to know to find a text in construction drawing is a big deal, because you have a lot of symbols, what looks like a text, but it's not really a text, like L, I, O, B, E. This is every time something what will, and you will find a lot of constructions what looks like this. But now we see we was able to recognize it perfect. Okay, so now I'm going to another sample so that I can show you how you can calibrate the coordinates, okay, and how you can vectorize the raster pictures. Let me take something different. Let me start the program from beginning so that I set everything on 0. We choose a spatial file, okay, and let me check it, how it looks. And this is something very unusual. Can you see it? Character, nothing. No path, nothing. Image, everything is only one raster image. And this raster image is made by CAD. Can you see? Minus connected with 4. Can you see here? Overhead, R connected with H connected with E. This is a disaster for any optical character recognition. This is really a disaster. And you have a filled walls, everything. You can't use for this kind of drawing any conventional normal raster to vector programs. If you want to see, I show you something. If you use a normal raster to vector methods, I will switch off every artificial intelligence methods. So this is simple without any artificial intelligence recognition. I switched everything off what is artificial intelligence so they can see how it works if you don't use any artificial intelligence methods. This is what you will get if you use on normal raster to vector methods, raster to vector software. You can find a lot of this software in internet. You will get something like this. Moment, there was one recognition less. I have to switch off. The wall recognition was there. I didn't switch everything off. Yeah, this is so. Okay, I switch it off. No artificial intelligence, no ethic. Now let me start it. And what I'm doing now is a simple raster to vector, simple center line tracing. There's no any intelligence. This is what we will find. It is every kind of raster to vector method. You see, look. Yeah, you can't use it. Look how it looks. Terrible. Okay. Can see? This is terrible. Text is not recognized. You can see this overhead. Can you see? Look. So I will save it so that we have this on our screen so that we can compare. Okay. And what I'm doing now, I will start now the artificial intelligence methods. Okay. And let me go here. Optimization. Line type recognition. layer recognition. Okay. Raster to vector. Line and symbol recognition. Wall recognition, solid walls. 45-degree horizontal lines. Fill small holes in pixel traces. I don't need to adjust it. Is everything okay? Vectorization 3. This is everything fine. Here, recognition of edge lines and corners. Let's make it a little bit smaller. What is it? This is a maximal line width in pixels. I show you something. And here, every kind of recognition. Let me check it. View input. Look, what's going on here? You see, you can see maximum. Here we have 2 pixels, only 2 pixels for line weight. But the question is now here, is this as a line or is this a wall? 1, 2, 3, 4, 5, 6, 7, 8, 9 pixels. The question here, is this a line or this is a wall? 1, 2, 3, 4, 5, 6, 7, 8. I need this as a wall. It's not a line. And this is the reason that I put here this parameter under raster to vector, vectorization 4, that the maximum line width in pixel is 8 pixels. If there's more than 8 pixels, it will be a wall. Okay, good. And here vectorization 5, everything. Now I'm going on optical character recognition. Okay, let me activate here first my automatic horizontal vertical text. Okay, but my text is only as raster picture. You can see here, and preview. Now we check it. What the artificial intelligence think it's now you can see we have a lot of mess. Can you see it? This is not easy to recognize this text between it. Okay, then this is the reason that we think, for example, that this is L. We of course we think this is L. So in this case, it's better you switch on the interactive recognition and you generate the text areas yourself. I can see there's something, but it's very tricky. I show you something. In this editor, you can help our artificial intelligence to see the difference between numbers and text. The problem is here that Latin letters and Arabic numbers, they use the same shapes. Von L und von 1, von O and for 0. B and 8 are almost the same. So this is the reason that if you go here on number areas, we know that here, look, you can see now I can look for horizontal numbers. Here, numbers, look here for horizontal numbers. Look here for numbers too. So you see, and here, look here, and you will be very surprised what I'm doing. Look here for numbers. Of course, we will looking here for the text too, but our artificial intelligence simply decide that this is more something like number and little bit text. Now I'm going here and decide here. Now I have a text area, and this is my vertical text, and this is my horizontal text. This is my vertical text, and this too. And here is my horizontal vertical text. Here's my vertical text. No, better go here and decide this is a number area. Number area is something like a symbol, you know. And then I'm going again on text area. This is what I need as a text. Okay, and here zoom. Okay, and this is what I need as a text too. Okay, and now zoom all. And this is what I need as a text too. Okay, and here this is what I need as a text too. Okay. Okay, and this is a question. Do you need as a text or not? You can define more, you can check it, but I'm finish it here, maybe this as the text. Let me make something upside down, okay? Then I show you how it works. You can make a text under inclination too. For example, upside down F. Text direction, here's the X. Vertical text, okay? If you had text under inclination, you do something like this, okay? Okay. This is very fast done. You need maybe 5 minutes for complicated drawings, but the quality is amazing. Now I'm going on coordinates calibration. You can see this is a scan, and in a scan, so you have the scan create a calibration points, because the scan is simple scan. There's no information about any coordinates. Let me go here. I put this point and I decide this have to be later coordinate 0, 0. And this have to be the coordinate 44 feet. And moment, I have here, I wrote it here, because you see the problem is here, it have to be in inches everything. And X is then 44 feet, and everybody know that is 5 to 8 inches. And Y is 26.8, you see? And this is 320 inches. Zoom it and move it really in the corner. So we will snap the corner and place here the absolute perfect coordinate. Okay, like this here. So, but we have more info. Can you see this one, this points? I have no already time, so I'm used only this one. You can snap this one, and you can tell, I don't know what is Y, but X have to be 10 feet, 120 inches. This, I don't know what is Y, but this have to be 360 inches. This is why I don't want to calibrate, because here is everything calibrated. Let me zoom it, and we will using a spatial artificial intelligence calibration for construction drawing. This is our invention, and this invention you will make a fantastic calibration for the full drawing. With this calibration, we'll never lost any parallel, vertical, horizontal lines. Do you want to see it how it works? Okay, save and edit. Okay, and start the conversion. And now the program is doing a lot. Wall recognition, symbol recognition, horizontal and vertical text recognition, recognition of coordinates, recognition of layers, recognition of symbol. This is our artificial intelligence is working really like crazy. And look what's going on. Now we get compared without artificial intelligence, with artificial intelligence. Look, native text, native text. You see 5.4, 5 minus 4, we was able to recognize it. Let me check it here in original. Look, because we know that this is living room, we was able to recognize it. We was able to recognize the walls and the windows. Can you see it? And now we have here exact. If you go here on ID and ask for the coordinate of it, it's exact 0, 0, 0. Can see? And if you go on ID and ask the coordinates, it's exactly 44 feet. Can you see it? So I'll put it here. 44 feet, 26.8. Like this drawing is perfect calibrated. And we got here layers. Look, we have layers. We have walls on extra layer. Like you have to leave only the walls. And native text. And we was able to recognize this as a text. We have perfect recognize the number. Can you see it? And this number, vertical and horizontal text. And this is the power of an artificial intelligence. Okay. And now I will show you something more, what you can do. Every time, if you convert the drawing, you can go here and you can put in a background your original drawing under vectorization tree. place PDF raster image in a background. We make it dark and 30% transparent, because then you can more you can correct errors, you can see the quality of the conversion. So this is what I recommend you every time. Simply put this raster picture in the background so that you can see how the conversion is working. Okay. And you see, I have now in the background the original drawing. And let me check here something. Let me check this one. So you can see the 10 is really correct, recognize. So we was able to recognize here a lot of symbols. You can see immediately the text, what we recognize. Okay. Stairwell, everything is there. And if you don't need it, simply go on it and switch it off, delete it, or switch it off after the conversion and after the control. You can also, if you have a simple drawings, you can start this conversion in CADdirect. And in CADdirect, we have very, very important function. I will show you something. If you go here on AI tools, you can import here the, let me check this with the first file, what I show you, show you today. I don't vectorize any, so pictures here really optimize. Okay, and when we start here the vectorization. Okay. And if you start it under CADdirect, you can immediately insert it in your drawing. That's what I'm doing now. See? So we have now this drawing. But I want to show you something. Okay. Let me go back to this drawing. Let me go here and we ask for distance. Look, the distance is 3 table. Okay, let me go here first on the units. So I put here the metric units, meters, because you can see this is meter and here is meters too. Okay, and decimal is fine. So now we are using here our assembly function, scale the XY coordinates. Scale it so that this distance, okay, have to be 4.34. Bang, done. And now if you measure it here, you can see that the distance here is perfect, 434. But if you will measure this distance, for example, this one, 365, this is 36467. What's going on? The problem here is that the PDF I convert here had a very, very bad accuracy. And if you scale the drawing, I will get this distance correct, but not the other distances. Why? Because scaling do not change the accuracy. And here I want to show you something in the last 3 minutes. We offer here in this CADdirect a fantastic function for correction of PDF coordinates. And this is the reason why we recommend to everybody who own Print2CAD buy CADdirect. We don't want that you quit your AutoCAD. Work with your AutoCAD. But in CADdirect, we have a lot of special functions. You can make your PDF to CAD conversion better. Look what I'm doing. You can calibrate the coordinates in X and the Y direction. X coordinates calibration. So I have not a lot of time, so I'm doing very fast here. So snap this one and this one. And simply you see, we can see that is 0, 1. Can you see 0.1? Simple enter it. Next one. We recognize this is 365, enter. bang, enter, bang, enter, bang, enter. And you can do it for full coordinates here and here. Here, we leave the symbols for you as information. We already calibrate these coordinates. You can here clean the calibration points, you see? But now you will be surprised. This calibration changed this distance. Okay. Now it's as a perfect 365 and didn't change any other distances. Like this stay. Moment, this was not wrong here. I have to calibrate it too. Okay, I have to do it again. Moment. It's mess up here something. Okay, we have to. So let me go here from beginning. Sorry, I mess up here something. So you go here, here, 3 for 3, then 10, bank 10, this one, 10, 1.5, 10, here, 1.5, dot 1, bank, and etc. Okay, let me go here and clean up it here now. Now look, distance 3, 4, 3, 4. Okay, this distance is exact 365. Can you see? But we calibrate not only this part, we calibrate the drawing itself. Now, if you measure distance, for example, from here to, I need vertical distance, moment, distance from this endpoint to this endpoint, look, we got exact 365. And if you measure distance from here to here, is exact 1.5. Like with the help of these dimensions, we was able to calibrate the full drawing. You see, this takes maybe 5 minutes work, but you will get a perfect drawing after PDF to CAD conversion with perfect coordinates. This is so powerful function, but this function, for this function, you need a CAD system, and we offer this function only based on our CADdirect. This was everything for today. Thank you very much for your attention. And Chuck is asking, can all PDF converting features be done inside the software and the computer as an internet or cloud connection required? So the problem is here following, okay? We can't send your drawing on the cloud and back because you will not allow it. This is a terrible situation for us. We are able to convert this drawing perfect on the cloud. But on your computer, we can't offer functions that are working a lot. You see, we have cloud computers rented by Amazon, and they are running 400 times faster than your personal computer. 400 times faster. This is parallel computing, and we are able to do everything on the cloud, but we can't do it. We can't send your drawing on the cloud and back. So this is, you can be sure that everything stays on your computer. And the limitation of AIs, Roger, are only your computer. The problem is here, as long as nobody trusts the cloud computing and the construction drawings your construction drawing can't leave your company. We have to do everything on your computer. We are able to do a magic. But we have to take your drawing on our computer, use on our computer our artificial intelligence methods with our high-speed computer and send it back. You can see if your computer is working 400 times slower than our computer, I can imagine how it works. so for function, what you need 1 minute, you need on your computer 400 minutes. Do you know how long is 400 minutes? This is your full working day. Okay, this is the terrible situation what we have. But in the future, maybe in the future, more users will trust for cloud computing and allow to send the construction drawing on the cloud, convert it in the cloud, and then get it back. So I have, Chuck, a lot of architectural modeling drawings, but this is a subject of my next webinar in 1 week. Okay, Chuck, visit my next webinar in 1 week. Okay. Thank you very much again for your attention. I have to finish now, and see you next week. Next week, I'm speaking a lot about this fantastic modeling, 3D modeling, okay, like this one here, and about RHC modeling, about walls, everything what we have. I'm speaking about the 3D mouses and what we have in our computer, but not today. Okay, see you next week. Okay, thank you very much, and again, and see you next week the same time. Bye bye.